Okay, so this is the first example we have. It is the relationship of volume, pressure, and temperature in a gas. Right now we're not going to hold anything constant. We'll put some particles in there. Temperature's staying at 300 Kelvin. Our pressure's going up. So you can see as you put more particles in, the pressure will go up, but eventually our pressure is going to kind of level out. Here's our heat control down here. And then over here, the little spaceman can change the volume. So, what happens if the volume gets smaller? Hopefully you saw that the pressure went up and the temperature went up, and it went to a point where the thing exploded. All right, so we'll try it again. So if we change the volume, we affect the temperature and the pressure. If we make the volume get bigger, our pressure's going down. All right, if we add heat, our temperature goes up and our pressure's starting to go up. If we remove heat, temperature goes down and the pressure's going down. So let's work with Boyle's law first. Boyle's law is temperature and pressure, or volume and pressure. So temperature is held constant. So we're going to hold the temperature constant at 464 Kelvin. What's going to happen to the pressure if the temperature stays constant? First of all, you'll notice when I moved it, we got some ice to cool it down. So the temperature is going to try and stay constant. What happened as our volume got smaller? What's happening to our pressure? Our pressure is going up. As our volume gets larger, our pressure is going down. And our temperature is staying the same. If we hold volume constant and we add heat, what happens to the temperature? The pressure. Temperature goes up, obviously. Pressure's going up. If we remove heat, pressure's going down. Temperature's gone down. So that's a direct relationship. That would be Gay-Lussac's law. Charles' law is volume and temperature, meaning pressure is going to stay constant. So if I cool this off, notice what happens to the volume. As the temperature goes down, the volume gets smaller. If I heat it up, notice what happens. The volume gets bigger. If you can get this loaded on your computer and play with it yourself, it's a lot of fun. This is the next page of your project or packet on Boyle's law. You'll see this diagram. What we're going to do is sketch a pressure and volume graph here. And the way we're going to do that is I'm going to make the syringe go, or piston, or whatever you want to call it. And I'm just going to start tapping on it as it opens. And we get a graph. What kind of graph is that? Draw that in your notebook. And then click this button and draw that in your notebook. This is the next page in your packet. We're going to drag the blue slider back and forth, and you're going to see a graph appear. So I'm going to take the temperature and I'm going to cool it off. And notice it's cool now, and the piston is lowering, so the volume is getting smaller, and we're getting a nice graph of it over here. Very exciting, isn't it? It's riveting. We're not down to 101 Kelvin yet, though, so I can't stop. All right, now we're going to take it to go the other direction. Why is it not showing me? Oh, there's our data table, or our graph. So sketch this in your packet on the page about Charles' law. For Gay-Lussac's law, we need to keep mass constant and volume constant. So now we can look at the effect of changing pressure. So here the pressure is going up. What happens when the pressure increases? The temperature increases. Here, in this example, new case. Now, what happens when the pressure increases, temperature increases, the pressure increases. So you can see it's a very simple relationship.